look at the unraveled exact couple for this situation, and this is really just a sanity check. This is essentially the same thing we've done before, but what's our setup? Well, remember now we were starting with some differential graded module that had a nice filtration. So let's say it has some bounded decreasing filtration. Thinking maybe of a chain complex, like the cochain complex, cellular cochain complex or something for a space. But in general, just something, some DGM with a filtration. Then we got a spectral sequence where we start with the E1 page being the homology of the filtration quotients. So I look at FPA, mod FP plus 1A, just because I made it a decreasing filtration, and that should cook up for me something that approximates the cohomology of my complex. And remember that in the cohomological setting, our differentials on the rth page are going to look like they have by degree r comma minus r plus 1. I always have to remember which setting I'm in. And now, essentially, as before, well, last time it was a co-fiber sequence, now it's a short exact sequence, but each of these filtration inclusions is going to give us a short exact sequence. And then I'm going to put the quotient here. And this will give us a long exact sequence in homology. Maybe I should say cohomology, since I'm thinking of this as having the cohomological degrees. So I'll have Hn of this filtered component maps to Hn of the next filtered component, maps to Hn of the filtration quotient. And this is just because any short exact sequence gives rise to a long exact sequence. Sorry, any short exact sequence of chain complexes gives rise to a long exact sequence in homology. That's what I'm trying to say. Okay, and here's my connecting homomorphism, wraps around. And continues. Okay, ran out of space a little bit there. But remember we called these maps I, J, and then our connecting homomorphism we called K. And so now we'll get an unraveled exact couple, just as we did before, though the degrees are a little bit confusing now that we're doing cohomology. So I just want to write it out, but it's exactly as it was before. Maybe let me put down here Hn of the P filtration maps to Hn of the quotient. I guess I must be going Fp mod Fp plus 1 here, and that wraps around by the connecting homomorphism to Hn plus 1 of the P plus first filtration, and so on. And so that goes down to Hn plus 1 of Fp, Hn plus 1 of the quotient. Now I'm realizing I'm going to run out of space, so let me give myself a little bit more room here. And that continues, of course. And we can even lift this back a little bit more. Okay, and then in another color, I'm going to draw a long exact sequence that I'll sew into this one. So I guess I'd want to have Hn of Fp plus 2 mapped onto this. That'll become green also, and map to the filtration quotient. And wrap around by connecting homomorphism. and that sews into this one, and so on. Okay, seem to be running out of space here. And let me just draw one more. So let's put in here HN FP plus 3. This becomes blue also. If I were slicker with my tablet, I guess I could have done some copy and paste maneuver and changed the colors and changed the indices appropriately, but I'm not that slick. Not yet, anyway. Okay, here I've got P plus 3. Coming down, goes over to the relative, or the homology for the filtration quotient. Oop, that should be a 2. Okay, of course, you get the idea. Same deal as before. I just wanted to write this out so that we could do a sanity check and make sure that things go where they're supposed to go. Oh, maybe before I do that, let me remind you, by abuse, I label all of these maps induced by the inclusion I, and then these are all J, and these are connecting homomorphisms we call K, and then these become J again, and K, and so on. Okay, and now remember that we said that D1 should be J after K. So over here I have my D1 really doing this K, oops, that was weird. Okay, this K and then this J. So there's my D1. And so some little A in this homology of the filtration quotient goes over to something here. And the idea is that if it goes to 0, well then I can lift it back to the previous term and look at something that's just K of A. And now I'm in the green long exact sequence and it went to 0 in the green, so I can lift it back along I for the green long exact sequence and find something in HM plus 1 FP2A and send that thing over. So my D2, I guess really what I want to write here is that this is D1. And then D2 is, well, it should only be defined on things in the kernel of D1, but it sort of roughly goes from things here to things here. So maybe I'll make that dotted since it's not an exact map. Exact is the wrong word. It's not an actual map between those two things. Okay, so I'm going to use the usual convention that n is p plus q as we did before. And remember our degrees here of our differential are supposed to be r comma minus r plus 1. So I just want to make sure that all went well with all of this notation. So I start at the pq spot on the E1 page. By definition, that's hp plus q of fpa mod fp plus 1a. And I see, oh yeah, that little a, it mapped over to hp plus q plus 1 of fp plus 1a mod fp plus 2a. And so now I have to figure out, oops, what that corresponds to on the E1 page. Well, the first filtration thing that we're quotienting by, or that we're quotienting, I should say, that's our first coordinate. And then this thing should sum to p plus q. So I guess we're just left with q. And now we see the differential, yes, it just went over 1 and up, not at all, as it should on the E1 page. Our D2, well, it's really a map on the kernel of D1, which lives inside E1 PQ. And as we had before, that's H P plus Q of FPA mod FP plus 1A. And then this thing should map to stuff that's in the kernel of D1 as it sits in, well, where did we lift that class to? We lifted it to something in H, I guess P plus Q plus 1, FP plus 2, I'm looking at that blue thing up there, mod FP plus 3, and that's E1, what is it? I guess P plus 2, and then Q minus 1. Whew, just slipped it in there. Okay, so that does, in fact, look like something on our page that's going to go over 2 and down 1, so that also checks out. Okay, so I went through that pretty quickly, but it's the same idea as before. Now I'm going to take that little a, and if D2 sends it to 0, well then I can lift that back in the blue long exact sequence to the thing right before it and say, oh, well if that went to 0, then there's something in the image of I that hits it, so I lift it and I play this game again. So really we just want to continue to play this game, and so we'll say if dr of a is 0, then we can keep lifting up the diagram. Okay, and as we said last time, kind of in the same not entirely true way, I want to write dr plus 1 as j after invert I r times, so lift back up through the diagram r times after k, and let me just scroll back up to this thing. Now, of course, that doesn't quite make sense because it's really only defined on kernels and there's all these quotients and subquotients going on, but I do see that that's essentially the game that I want to play. Let's see if I can find my pointer. So if a goes to 0, then I can lift it back to something, lift that back and send that over. And if that goes to 0, well, then I could lift that thing back and send it over and across and play this game. And so really what I end up doing is taking a over, lifting it up the diagram r times and mapping it over. And now as soon as that differential is not 0, then this element will essentially die in our spectral sequence, right? It'll become a boundary and we'll be done. So again, this is kind of a lie, but this is roughly the idea, is that we should do k, we should lift up the diagram along I r times, and then do j. Okay, so I just wanted to spell that out in detail so that we can now look at not the unraveled exact couple, but what's just called an exact couple, the succinct version of this.